Hi guys, so today we're going to move on to 6.2, which is describing functions, and we're going to go over some of those vocabulary words that you saw during your pretest that you weren't quite sure about. So we had linear and nonlinear, and linear basically just means a straight line. Okay, so you can have a table, an equation, a graph, and all of them can represent a straight line, and we would say that that's a linear relationship. Nonlinear, on the other hand, would just be a relationship that does not form a line. It would be curved or it'd be jagged or would have some sort of a wave. Proportional, if you remember from seventh grade and actually earlier in the year, the equation for a proportional line was y equals kx. K was the constant or proportionality. So if we had a table, when you divided your y value by the x value, whatever quotient you got every time was called the constant of proportionality. When you saw a line graphed on a coordinate plane, if it went through the origin, it was proportional. If it didn't go through the origin, it was not proportional. Okay, and same with a table. If you divided your y value by your x value, you would not get the same quotient every time in a non-proportional relationship. All right, so for example one, we want to look at linear lines, linear, nonlinear, proportional, or non-proportional. So this example says the temperature at dawn was 8 degrees and increased steadily at 2 degrees per hour. The equation y equals 2x plus 8 gives the temperature after x hours. Is the relationship proportional or non-proportional? Graph the function. Okay, so we can tell whether this is proportional or not proportional right off the bat. If we look at the equation y equals 2x plus 8, if it was proportional, it would stop right here. It would stop at the y equals 2x. But because it has this plus 8 at the end, that's telling me that it's not going to go through the origin. Okay, that's telling me that it's going to start at 8. At the beginning of the school year, we graphed equations in y equals mx plus b form, slope-intercept form. And if you remember, this number out here was our y-intercept, and that was the point that we started. Okay, so we already know that this is non-proportional, but we're going to graph it and just show you. So you can always make a table of values. So that's what this is right here. It's just an XY chart. We can make a table of values to figure out this equation. Okay, so the equation was y equals 2x plus 8. I can choose some values that I want to plug in for x. So I'm just going to say 0, 2, 4, and 6. Those are values that I want to plug in for x. If I plug in 0 for x, then I'm going to get a y value. So let's do that. What's 2 times 0? Okay, if I plug in 0 for x. 2 times 0 is just 0. Plus 8 is 8. Okay, so if I plugged in 0 for x, 2 times 0, and then added 8, I would get 8. Okay, so now we're just going to move on to our next x value that we chose at random, and it's 2. So come over here, and we're going to plug it in. 2 times 2 is what? 4 plus 8 is 12. Okay, then I'm going to plug my third x value that I chose in. Okay, I chose 4. So come up here, plug in my 4 for x. So 2 times 4 is 8, plus 8 is 16. Okay, and then my last x value that I chose was 6. So again, I'm going to come up here and I'm going to plug in that 6. 2 times 6 is 12, plus 8 is 20. Okay, so I just made myself a set of coordinates by making this table. I just made myself a set of coordinates that I can plot on my graph to make my line. Okay, so my first coordinate is 0, 8. So 0, 8 is right here. My next coordinate ordered pair is 2, 12. So 2, 12 goes right here. My third coordinate is 4, 16, which is right here. And my fourth coordinate is 6, 20. So 6, 20, which is right here. And then I can graph my line. Okay, and you can see from the graph that no, it does not go through the origin, which is what we said to begin with, and it is not proportional then if it doesn't go through the origin. Okay, I put this other graph here just so that we can refresh our memories on graphing an equation in y equals mx plus b form. Okay, so we have y equals 2x plus 8. What's our m and what's our b? Okay, well, we already set up here that our b, remember b stands for y-intercept, is positive 8. And then our m, which is our slope, has to be this one right here, okay, 2. And remember, we want a rise and a run to graph our slope, so we're just going to put that 2 over 1. All right, so to graph it, I'm starting at my b, which is 8. And then my slope tells me to go up 2 and over 1. Okay, so I have to pay attention to how my axes are labeled. My y-axis is going up by 4s. Okay, so half of every square is going up by 2. Okay, and then I have to also pay attention that my x-axis is also going up by 2. So that means the 1, 3, 5, 7, and 9 are halfway in between. Okay, so if I started at 8 and I went up 2 and over 1, that's going to put me here. Up 2 over 1, up 2 over 1, whoops, up 2 over 1. Okay, and I'm getting the same line. I just have more points. Okay. So it's the exact same line. I just have more points over here when I graphed it because I don't have enough room to put all of the numbers on my coordinate plane. Okay, so you can do either one of these techniques to graph your line. You can make yourself a table of values, plug in some values for x, solve it, and then graph your points. Or you can use what we did previously and plot your y-intercept, which is your b, and then use your slope to get to the next point. Okay, regardless, this is non-proportional because it doesn't go through the origin, and it is linear because it is a straight line. All right, so let's look at example 2. So example 2 says a square tile has a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. Determine whether the relationship between x and y is linear, and if so, is it proportional? Okay, to tell whether an equation is linear, it's pretty easy. If your exponent or your variable has any sort of exponent on it, it's not going to be a straight line. Okay, so right here, this x is x squared. All right, it has an exponent. Again, once you put an exponent on one of your variables, it starts giving you curves or waves. So this is not going to be linear. I can tell already. All right, so it's not going to be linear. All right, so I don't even need to graph it to tell that. Proportional, well, we'll find out. Okay, so y equals x squared. Let's plug in some values again. Let's do 0, 1, 2, and 3. Okay, so if I plugged in, let me write my equation down here, y equals x squared. Okay, so I'm going to choose 0 for my x value. Okay, and just plug it in. Y equals x squared. If I said x was 0, what's 0 squared? Well, 0 times 0 is just 0. How about if I plugged in 1 for x? Y equals 1 squared. What's 1 times 1? 1. How about if I plug in 2 for x? Okay, y equals 2 squared, okay, or 2 times 2, when we get 4. And then y equals 3 squared is 9. We're going to plug in each of our coordinates on the graph and see what we get. Okay, so our first point was 0, 0. Our second point was 1, 1, which is going to be right about here because my y coordinate is going up by 4s. My third coordinate is 2, 4. And my last coordinate is 3, 9. Okay, which is going to be right up in here. All right, so you can see that my line is not a straight line at all. It's a curve. Okay, so just like we set up here, it's not linear. I could tell because I had an exponent on my variable. It's also not proportional, even though it goes through 0, 0. Okay, the rule for proportional is it has to be a straight line that goes through 0, 0. Since this line is non-linear, it doesn't matter that it goes through 0, 0. It is not proportional. Okay, so proportional has to be linear. All right, so I'm just going to write that up there. And that's it.